Hey guys, in this video I'm going to go over the first section within the 6.5 operations with radical notes. So I'm looking at examples 1 through 6 in your packet. So as you're watching this video, please follow along and make sure you're completing the questions in your note packet. I will be making a series of videos for 6.5. This is only going over the concept of simplifying radicals. Okay? Once you get the hang of this, if you're ready to move on to the next video, feel free to do so. Alright, so in this section, all we're trying to do is get the radical simplified down as far as possible. And this is something that we've done throughout the year, so some of you guys will probably be pretty comfortable doing this already. But I am going to go through each step on how to do that right now. So let's take a look at our first example. Example 1, what is the square root of 18? And I want to simplify that down. So I'm going to show you two methods for simplifying radicals. So method 1, this is the method I like to do, is looking at the radical. So we know this is a square root because there's no number here. I want to figure out, are there any perfect squares that are a factor of the number underneath the radical? So 18 is the number, right? I'm thinking of, is there any perfect square factors? Well, 9 goes into 18. So I'm going to rewrite number 1 like this. I'm going to say, instead of square root of 18, I'm going to say square root of 9 times the square root of 2. Now if I multiply those together, I get back to the original radical 18. Now why did I split it? Well, what we learned earlier in the year is square root of 9, this here, that's 3. So this is really 3 times radical 2. Okay? 3 radical 2, and then that doesn't go any further down. 2 is a prime number. It's not going to have any factors that are squared numbers. So 3 radical 2 is the answer to number 1. So that's the method I like to take, but there are times that it can be difficult to identify perfect squares, and I get that. So there's a second strategy, and we did talk about this early on in the year. I don't know if anybody's using it, but I'll remind you it now. And that second strategy is writing it as its prime factorization. So 18 could be written, let's see, what's its prime factorization? Well, I know it's 9 times 2, and then 9's broken down to 3 times 3. So the prime factorization for 18 is 2 times 3 squared. Okay, that is 18. Alright, now how does that help us when simplifying radicals? Well, whenever you're simplifying a radical, if you're doing it this way, what you're looking for is there repeat factors within the square root. So I broke down 18 to this, so I could write it like this, 2 times 3, and I could put squared, but I'm just going to put 3 times 3 for now just to emphasize something. So since this is an index of a 2, square root, if there's 2 of one number, which we do have that, we've got 2 3s, what you could do is you could pull one of them out. So for every 2 underneath is equal to one number outside of it. Alright? So 2 3s underneath, well, I could pull out 1 3, and both of these 3 are accounted for with that 3 being pulled out. And then I still have this radical 2 that I can't do anything with. So, oops, not a 3, a 2. So I get 3 radical 2. Oops, try that again. Alright, and you can see these are the same answer, right? So both of them are great strategies. I feel like the first technique is a little quicker for me, but if you like the green, what I did in the green here, go for that. That works every time as well. Let's try number 2. So I'm going to go with my strategy first. So 216, does it have any perfect square factors? So I'm going to take 216 on my calculator and start dividing it by some perfect squares. So I'm going to try 16 to start. Let's see, does it work? No, it does not. 16 times 13.5, so that doesn't go into it. Well, let me try another one. 36, let's try 36. That's a perfect square. Okay, so it does work. 216 is divisible by 36. It's equal to 36 times 6. So I could rewrite it as the square root of 36 times square root of 6. Well, the square root of 36, I know that to be 6, and then I still have my radical 6. Okay, so this strategy, there's more time spent on figuring out the factors, but I still feel like that's going to be quicker than doing all the way down to its prime factors. Okay, now if you like the prime factors though, please do that. I'm not saying that this strategy is necessarily better. I just think it's quicker. All right, so here is strategy 2. So let's go through strategy 2. So strategy 2, I'm going to start dividing it all the way down to the prime factors. So I do know that it's 6 times 36. That's something that goes into it. So I'll start with that. But I got to keep going all the way down to its prime factors. 36 is 6 times 6. And then 6 isn't a prime number, so I need to break that down some more. So 216 is the same thing as 2, 1, 2, 3. So it's 2 to the third times 1, 2, 3, 3 to the third. So how does that translate to this here? So let's go ahead and do that. So I could write this as the square root of 2 to the third times 3 to the third. And remember what I said a minute ago is whenever so our index is a 2, it's a square root. Whenever I have 2 of one number, I can pull it out, right? So I've got 3 2's underneath the square root. Therefore, I could pull out 1 2, but I'm going to have 1 2 remaining, right? So let me write this out in its expanded form so you can kind of get what I'm saying here. So for these 2, I could pull 1 out, right? And now they're accounted for, so they're not going to be underneath. So I'm pulling out that 1 2, but I still have that 2 left underneath. And then for these 2 3's, I can pull out a 3, and now they're accounted for, but I still have this 3 left underneath, right? So I've got a 2 pulled out, a 3 pulled out, and I've got a 2 underneath and a 3 underneath. So what this turns into is 2 times 3 is 6, right? And 2 times 3 underneath is also radical 6. So same answer here, just different strategies. Alright, go ahead and pause the video and give number 3 a try, and then resume when you're ready to check your work. Okay, hopefully you've had an opportunity to try number 3. So what I'm going to do here is just start checking some perfect squares. So 324, is it divisible by, I'll start with 16. It does not go into it. 324, is it divisible by 36? Yes, it does. But when I look at what's left, so 324 is 36 times 9. But this is telling me something because both of those are squared numbers. I'm guessing 324 is a perfect square itself. Let me check. Square root of 324. Yeah, it is. It's 18. So I'm glad we had a problem like this because if you're not sure, it is probably a good check just to see, is the number a perfect square that we're starting with? Because that's going to make our lives a lot easier if it is, right? So 324, square root of that is 18. I've already taken care of the integer part. So now I'm looking at the x to the 4th part, right? So I'm thinking of this as 2 parts. I'm thinking of it as the integer part and then the variable part, right? So square root of 324 is 18, and then the square root of x to the 4th, well, like we said earlier, if you have 2 of one thing, you can pull it out. Well, I've got 2 x squared, so I could pull 1 out. Or another way to think of it is x to the 4th, the square root of that would just be x squared. So I've got 18x squared, nothing left underneath the radical. Okay, let's move down to the next 3. See if we can finish this in the 15-minute timer. Okay, so this one we're doing other roots. So the reason why I like showing that second method up top is because that's where that second method is going to be probably the best method for most of us here, because in these problems you have to remember other numbers besides squared numbers. You might need a cube number, like we have in example 4, or something to the 4th power. So by doing the prime factorization, it's a little easier once you get down to these types of problems. All right, so let me show you what I mean. So 8 is 2 times 4, and 4 is 2 times 2. So 8 is 2 to the 3rd. Well, my index is a 3. So since it is a 3, in order to pull something out, this time we need 3 of that factor. We need it to be a cube number to pull out. Okay, so looking at square root of 8, knowing that it's the same thing, not square root, cube root of 8, it's the same thing as the cube root of 2 to the 3rd. Hopefully we can see we've got 3 2's. We can pull out a 2 because the cube root of 8 is 2. Okay, so I'm pulling out a 2. And then looking at the x to the 6th, think of it as x squared times x squared times x squared. That is x to the 6th. So if all of that was underneath a cube root, if I've got 3 of the same thing, I can pull one out. So I can pull out an x squared. So this is just 2x squared. Another thing to know is, one thing that you can do is you can divide the exponent by the index. If it goes into it evenly, then there's nothing left out underneath the radical. 6 divided by 3 is 2. And check that out. I got x squared pulled out. Okay, let's try another one. Okay, so I've got 64, and this time our index is a 4, so we're doing a 4th root. So 64, I'm going to start by looking at 64 and breaking that down. I know that 8 times 8 is 64. 8's 2 times 4. So this breaks down into all 2's. It's 2 to the 1, 2, 3, 4, 5, 6. So 64 is 2 to the 6th. Okay? So how does that help me? Well, I'm going to rewrite my problem. This is the 4th root of 2 to the 6th. And then I still have the x to the 7th. So I'm going to put the x to the 7th underneath here as well. So 2 to the 6th, for this problem, I need 4 of the same factor in order to pull one out. So if there's 6 of them, I'm going to write it like this. That's the same thing as 6, 2 to the 6th. 2 to the 4th, that can be pulled out. Okay, I got 4 of those factors of 2. But I still have a 2 squared left underneath. Okay, so don't forget that. And then now let's take a look at the variables. So I'm going to flip colors, focus on the variables here. Alright, so I've got 7 factors of an x underneath my 4th root. I need to have 4 in order to pull one out, right? So if I pull out, so I'm going to rewrite this as x to the 4th times x to the 3rd. So this will allow me to pull one out, and I'm left with 3 underneath. So I've got 1x that I could pull out, because I had x to the 4th underneath. And then I still have that x to the 3rd left underneath. So let's put what's underneath back underneath this radical. So I've got 2x pulled out, and then 2 squared is 4, and then x to the 3rd is just written as x to the 3rd. So this simplifies to 2x 4th root of 4x to the 3rd. Alright, go ahead and give number 6 a try and then resume when you're ready to check your work. Alright, so 3 to the 3rd is the same thing as 27. Cube root of 27 is 3. Pull that out. So I've considered the integers. B to the 18th, well, I'm going to do that division trick I showed you a second ago. 18 divided by 3 is 6. The nice thing here is it goes into it evenly, so I can pull out a b to the 6th, and then that's accounted for. And then c to the 12th, 12 divided by 3 is 4, so c to the 4th can be pulled out. and that goes into it evenly, so that's accounted for. All right, thanks.